Put your chair down, Corbin. Thank you.
Put your chair down, Corbin.
All the way.
All the way.
Would you like to stand?
I don't like being neurotypical. You guys stink.
Okay, so I tried to make a concise summary page with the important things so when you go home and study like you always do for tests, you know exactly what to look at. Okay, the first things, your Rolle's theorem, mean value theorem. You have to know these criteria. It does you no good to find the value if you didn't check the criteria. Rolle's theorem has 3 conditions. So, what's the first?
Continuous.
Hmm?
On the closed.
On the closed interval, I'm just going to say A to B. You guys know what I mean, right? All right, what's the second criteria?
Differentiable on the open interval of A to B.
That was closed.
That's open. Closed is continuous.
The derivative doesn't have to exist at the endpoints. It can, it just doesn't have to. And what's the third criteria? What is it? The endpoints are equal. So f of A equals f of B. If those 3 conditions are met, then what's true? Yeah, there's somewhere where the derivative equals 0, or max or min. So the result, f prime of x equals 0 for some x between A and B. All right. Mean value theorem. I have too many bullets here, but what's the first criteria? Bless you. So it has to be continuous on A to B. Second criteria. On the open interval A to B. There is no third criteria for mean value theorem, just 2. And what's the result? So the derivative equals the slope between the endpoints for some x between A and B. All right. So we know those 2 things. Basically, you check your criteria, then you do your derivative and set it equal to 0 if you're doing Rolle's theorem, the slope if you're doing mean value theorem. All right. Critical points. How do we find critical points?
Derivative.
So it's where f prime of x is 0 or undefined. And what occurs at those points? Look what max and min happen here. So that's also where you find your increasing, decreasing from that. What's an inflection point? Where the second derivative is 0 or undefined. And what happens at those points? Okay. The critical points we use for the local maxes and mins, how do you find the absolute max and min?
Set the critical points and the end points. Plug them in.
Right, we find the critical points. Plug critical points. And endpoints into original equation. And we know then the highest is our max and the lowest is our min. If I don't give you endpoints, can you find the absolute max and min? No, we have to have endpoints in order for that to work. All right. I just want to draw a little sketch of what a graph might look like for each of these things. So what would a concave up and increasing graph look like? Increasing, curved upward. Concave up, but decreasing. Flips it around. Okay, what's concave down and increasing? And concave down and decreasing flips it. So you guys understand concave up and concave down, how that appears on your graph. All right, how do we find vertical asymptotes? So it will always be x equals a number, and it's where the denominator equals 0. All right, what about horizontal asymptotes? Good. So it will be y equals a number, and to find it, we do the limit as x goes positive and negative infinity. And you guys remember the trick for working out those limits? We divide everything by the highest power of x, so we could evaluate them. All right. Let's look at, then I did an actual example, because this is something we had a little more trouble with. And I apologize, looks like I should have put one more space in there.
It's okay.
Sorry. Thank you. All right. So, if this graph is f of x, so this is the original function, can you tell me the x values of any maximums and minimums? So, if this is the original, where do we have a max?
-1.
Okay, where do we have a min? Negative, let's see, this would be negative 4 point,
It's like negative.
negative 4.75. Each line represents a half on this. And where else?
2.75.
Okay. If this is my original graph, where would the inflection points be? So inflection is where our concavity changes. Can I just say, oh, here's an inflection point because it's curved down, and here's an inflection point because it's curved up? No, we change somewhere in between those. So usually it's the middle in between there, not always. But if I were trying to estimate halfway in between, I don't know, -1 and positive, well,
Oh wait, no, it's actually -3.
-3 and +1. Looks like where the concavity changed. All right. Number 2. I'm going to change it. Now, let's say this is the graph of the derivative. Okay, so I'm looking at the first derivative. I want to know where the maximums and minimums occur. So think about it. We find maximum and minimums from our sign line, right? You do the first derivative, you find your critical points, and we put those on the sign line. What are critical points? When the derivative is 0. So if this is the derivative, it's 0 at -6, -3, 1, and 4. So those had to be the critical points. All right. Then we decide if our graph is increasing or decreasing by looking at if the derivative is positive or negative. So before we get to -6, the graph was positive. So that meant the original was increasing. So we have a positive. Then in between -6 and -3, it is negative. Between -3 and 1, between 1 and 4, and after 4. Okay. So this is like the sign line we would see when we are drawing our graph and trying to decide increasing, decreasing, max, and min. So what's -6 going to be?
Max.
A max. Okay, at -3 you go from decreasing to increasing. So that's a min. At 1, we have a max. And at 4, we have a min. Is everybody okay with that? So inflection points are where the concavity changes, or when the second derivative equals 0. If this is the first derivative, I'm asking when will the derivative of this be 0? So what do I need to look for on this graph? The max is immense. Anywhere we would have a horizontal tangent line, my derivative would be 0. And those are the inflection points. So that happens at 4.75, -1, and positive 2.75. Does that make sense? I want you guys to try the next one. So same thing. I apologize, part of your directions are on the bottom of that first page. First do it if you're looking at the original function, and then think of it if you were looking at the derivative. So if I'm looking at the original function here, where do we have a max? Come on, you guys have had enough time to look at this. Where's my max?
-1, -3, positive 0.5, positive 4.
You guys agree?
Yep.
Okay, so our min, we have a min here, here. Do we count endpoints?
No.
Not for local maxes and mins, only if I ask for global, and I should have specified here, but I'm looking at the local max and mins. So those would be at,
3,
okay,
-1.
is it -1?
Oh no, it's
Neg-
like actually. Oh no, I wrote -1 point.
-1.5?
Yeah.
Okay. Inflection points are where the concavity changes, so that has to change between these. So here we're at -3, -1.5. Somewhere in between those, my concavity changed. Obviously, we are estimating. What does that look like to you?
Probably like
Negative
-2.25.
That's what I was going to say. All right. And then we changed between here and here. So where does that look like approximately?
-1.
-1-ish or -0.8-ish, somewhere in that ballpark. And then between these, so probably +2-ish. All right. Now let's pretend we're looking at the derivative. So if this is the derivative, my max and min are going to occur where we switch between increasing and decreasing. Your max and min are your critical points. So that's where the first derivative is 0. Do we count the endpoints?
No.
No. So we are looking at, what do we call these?
-2.
Okay.
-1.
Okay.
2.
All right, so we hit the x-axis 3 times there. Before -2, our graph was
Positive.
between -2 and 1,
Negative.
between -1 and 2,
Positive.
and after 2.
Negative.
All right, so we have -2, we go from increasing to decreasing, so that would be a max. -1, decreasing to increasing, so that would be a min. At 2, increasing to decreasing would be a max. Inflection points. So if this is the first derivative, the inflection points are going to be where the next derivative is 0. So when I'm looking at this, how do I know where my next derivative will be 0?
The maxes and mins.
The maxes and mins. It's where we have those horizontal tangent lines. So that would be at
-3. -1.5. A half. 3. 4.
All right. I know we struggled with these graph ones yesterday. Did this help?
Yeah.
Okay, so if I gave you a graph of an original or a derivative, you could turn around and answer those questions.
For sure.
Okay, so that's what I kind of pieced together after yesterday. I'm just trying to go through all the different pieces you need to know, as well as the graphing focus, because I knew we struggled. What? Put some questions up here. You guys can try. And I'm just warning you,
Oh, this is good. This is good.
I have never worked out these problems. I'm just pulling something, so we'll hope for the best. How nice do you want these problems to be?
Kind.
Kind of enough.
How do we find the absolute max and min?
Derivative.
Derivative. So the derivative here is 3x squared minus 12x. And how do we find our critical points? Okay, so we could take out a 3x, and that leaves us with x minus 4. So the critical points are 0 and 4. Are they both on your interval? Yes, so we have to test -3, 0, 4, and 5. You are plugging these back into the original, so hopefully you guys have done that. When you put in -3, what'd you get?
-76.
Thank you. When you put in 0, we get 5. What do you get when you plug in 4?
-27.
And 5. So what's my max
5.
and my min?
Oh my gosh, this is the first time I've actually plugged some in and actually got the correct
Oh.
I mean, to be fair, I'm not double checking, but I'm assuming you're right.
I don't know.
Okay.
I wouldn't.
Then let's look at the second question. So, critical points, increasing, decreasing, max, min. What do I have to do? Derivative. -6x squared plus 6x plus 36. What would you do to that? I'm going to plot -6.
Yeah, that's fine, dude.
And we want this to equal 0. So we have -6 is factors in x minus 3, x plus 2. So my critical points are -2 and +3. We do those on the sign line. So we need test points. Where do you plug those test points in?
The derivative.
Derivative. If I put in -3, I have negative times negative times negative, negative. Put in 0, negative times positive, it's positive. And 4 gives me a negative. So we are increasing from -2 to 3. Decreasing infinity to -2. 3 to infinity. Max and min. Where would you have a max?
-2.
A max? 3.
Oh wait, I did that actually so backwards. Just kidding.
The min is at -2. So you plug those into the original. So if you put in a 3, what do we get?
81.
Thank you. And if you put in -2, -44, thank you. Okay. Then we need inflection points. So second derivative. Okay, so that would be -12x plus 6. Set that equal to 0 and you get 1/2. So that's my inflection point. Okay, before that it would be positive, after it's negative. So we are concave up, negative infinity to 1/2. Concave down, 1/2 to infinity. Okay, so then when you plot this inflection point, you need an actual ordered pair. So to get that, you have to plug the -1/2 into the original. So tell me what that is. Anybody plug -1/2 into the original? Huh? Oh, sorry, +1/2. I wrote +1/2. I just said negative.
Oh, wait. Maybe.
No, it's +1/2. That's what I have written down.
Yeah, it's making sure I wasn't wrong.
What'd you get? 18.5. Okay. So then when we plot all of this stuff, I'm going to count by tens. So we had 381 was the max. -2, -44 is a min. Inflection point, 1/2, 18.5, we mark that with an X. Okay, our graph starts out, it's concave up, so curving upward until we get to that X. And it is decreasing until we get to -2. So we're decreasing, curved upward. -2, we switch to increasing, but we're still curved upward. With that, we're curving downward. And then switch back to. Isn't that beautiful? I didn't do one with the asymptotes and everything. I don't know if I got a little time. Do you want me to try one, or do you think you got it?
I got it.
You know how to find your asymptotes and plot those and everything?
Just do practice, just limiting, not even figuring out yet. So it's just doing, just to get specifically.
Okay, so if I said function, let's say x plus 2 over x squared. So what would the vertical asymptote be here? Horizontal asymptote will be y equals, and then we have to do our limit. So limit x approaches positive or negative infinity. And what's our trick? What do we do? So x over x squared would be 1 over x. 2 over x squared over 1. And then at this point, anything with an infinity on the bottom is going to turn into 0. So we get 0 plus 0. I know it's not, but just, if this were the first derivative, can you tell me by looking at that, what are your critical points? 0 and -2. When you have those fractions, when you're doing critical points and inflection points, you have to look at both the top and the bottom. That's where it's 0 or undefined. Don't forget the bottom. Do you want me to do anything else with this problem?
Just wanted to